Most people hear the term gamma frequencies and immediately assume they are fundamentally different from other brainwaves in a way that directly explains intelligence, awareness, or even peak mental performance. But when you actually look at what neuroscience says, the distinction between gamma and other brainwave bands is both more precise and more subtle than the way it is usually presented. To understand what makes gamma frequencies different, you first have to understand what brainwaves actually are. These are not physical waves traveling through the brain like sound waves in air. They are patterns of synchronized electrical activity generated by large groups of neurons firing together. When scientists measure EEG signals, they are capturing these rhythmic patterns and organizing them into frequency ranges for analysis. Those ranges include delta, theta, alpha, beta, and gamma. Each one is associated with different patterns of brain activity, but none of them represent a single isolated function. Instead, they reflect broader states of processing that overlap and interact continuously. So gamma is not something separate from the rest of the brain. It is part of the same system operating at a different rhythm. Gamma frequencies are typically described as the fastest measurable brainwave band, often associated with ranges above roughly 30 Hz. Because of this speed, gamma activity is often linked in research to moments where the brain is integrating information across different regions. For example, when attention is highly focused, when perception is binding multiple sensory inputs together, or when complex cognitive processing is occurring. But here is where a common misunderstanding begins. The fact that gamma activity correlates with certain mental states does not mean it causes those states in a direct or isolated way. It also does not mean that increasing gamma activity automatically leads to higher intelligence or enhanced cognition. Correlation in brain activity is not the same as a controllable switch for mental performance. Other brainwave bands show similar patterns of association. Alpha activity is often linked to relaxed wakefulness. Theta is commonly associated with drowsiness or deep internal processing. Beta is more active during alert thinking and problem solving. But again, these are not separate modes the brain switches between. They are overlapping rhythms that shift in dominance depending on context. What makes gamma interesting compared to other frequencies is not that it is superior, but that it appears during moments of high integration. In other words, when different parts of the brain are working together in a more synchronized way, gamma activity is often present. This has led researchers to explore its role in attention, memory, and conscious perception. However, even this interpretation has limits. Measuring gamma activity is technically challenging. EEG signals can be noisy, and high-frequency activity is especially sensitive to artifacts like muscle movement. This means that what looks like gamma activation in a reading must be interpreted carefully, not taken as a direct window into cognitive enhancement. Another important point is that gamma does not operate in isolation. It interacts with slower brainwaves like theta and alpha in complex ways. Some theories suggest that these interactions may be more important than gamma itself. In other words, it is not the presence of one frequency that matters, but the coordination between multiple frequencies. This is where the broader picture becomes clearer. Instead of thinking of gamma as a special brainwave that unlocks higher consciousness or improved cognition, it is more accurate to see it as part of a dynamic system of rhythms that support different types of information processing depending on context. So when people ask what makes gamma frequencies different, the most precise answer is this: gamma is the fastest commonly observed brainwave band, often associated with moments of high-level integration and active information processing, but it is not functionally separate from other brainwave activity, nor is it independently responsible for cognitive enhancement. The brain does not operate like a set of isolated frequency channels. It operates more like an orchestra, where different rhythms emerge, overlap, and shift depending on what the system is doing at any given moment. And gamma is just one section of that orchestra, not the conductor. A structured breakdown of how different brainwave bands interact can help make sense of how neuroscience actually interprets these signals without overstating what any single frequency can explain. If this perspective helped clarify the topic, subscribing can help you explore more breakdowns of how brain activity is interpreted in real neuroscience research versus popular explanations.